summertime. I mean, it's summer outside, but not that much inside. I'm very happy that the first two sessions, today and next week, will be international, which means that both the talks will be in English, which I think is a good training for both sides. Today, Natalia Kujeval will speak about the exploitation of the KonText tool for search in Lindat Repository. And I think next week we have a kind of topic which is not that much different, at least from the point of view of the authors. So please, the floor is yours.
Hello. So I'm very glad to see you all here. My talk will be about Corpus Query to KonText and how we adjusted it to query the data, the corpora from the Lindat Repository. So my talk will be structured as follows. First, I will describe the Lindat Repository. Then I will briefly describe the tool KonText and say something about the interconnection between KonText and Lindat. Then in the main part, I will demonstrate several queries over different Lindat corpora. The Universal Dependencies, or UD, which is quite famous treebank now, and also some queries from the Prague Dependency Treebank and queries from over some other Lindat corpora. And because this project, Lindat KonText, is actually in its beta version, so it is still under the development. We have a lot of plans for future and still a lot of to do on this project. So let's start with the Lindat repository. What is it and what does it include? 2 centuries ago, people thought about having all their work in one place. And so it is exactly what the Lindat is. Linguists can upload their data to the repository and can access all of those corpora that are already uploaded, and they can download it and cite it and do many things in the repository. So this is a very good idea because here is the statistic of the downloads from the repository, and you can see that it is quite impressive. The repository contains several types of items. There are 3 main types of the items. They are corpora. They can be either plain text corpora or syntactically annotated corpora or corpora with some other linguistic annotation. Lexical resources include dictionaries, valency lexicons, some other types of information, and tools and services. These are, for example, Corpus Query engines or machine translation systems or parsers, taggers, and so on. So in this presentation, I will probably stay here because I will show you many things on the web. So let's have a look at this repository. Here is the main page of the repository. Let us have a look on it. Here is the number of items, so you can see that the repository contains more than 1,000 items. But actually not of those items in the repository have the files attached to them, so some of them are metadata actually. And here you can filter according to if it contains files or not. So if we click yes, so you can see those items, those corpora that really contain some files. So you can also filter out according to the type, so you can see corpus, tool services, lexical resources, and so on. So let's try so let's have a look on one item that I will talk a lot about today, and it is universal dependencies. Probably a lot of you heard about this. There are several versions, universal dependencies 1.1 and 1.2, which is the latest one. Let's click on it. I think now it is one of the most downloadable item in the Lindat repository. So here you can see the item, the authors, and some other information like URL, the description, the languages that are involved, and here you can download all these tree banks. And now I will show you how it is connected to KonText. The KonText is actually a service over this tree banks. So you can click on it and you can browse these tree banks via the KonText. When you click, you can see many languages, and let us, for example, try English. And here you can browse the probably. I think that many of you already see this interface, this query interface, and here you can enter any query you would like and query any tree bank of those 38 tree banks from the Universal Dependencies. So let's just try to have some query. Oh, sorry. It was meant for some other. So I will give the examples of the queries over the universal dependencies later. Now I will go to KonText tool. So this is a brief. I will now explain briefly what it is. It is a Corpus Query system. The first version was called Bonito, and then after it was developed in the commercial form, lexical computing. So the version Bonito 2 is actually a sketch engine, and it comes into versions commercial and no scale. The commercial version of a sketch engine includes many functionalities, many nice functionalities like word sketchers, but unfortunately in our version we do not have the word sketchers because it is a commercial version and we have to pay for this. The KonText is a user interface developed by the Institute of Czech National Corpus, and it is forked from this Bonito 2, from the sketch engine. And in turn, our KonText, Lindat KonText, is a fork from this KonText of the Czech National Corpus, because the development in the Czech National Corpus is very open sourced, is an open source, and we can also contribute and see all the changes that is done there. So here it is the overall statistics of the KonText. You can see that quite a lot of people use it so far, but I have not analyzed where they're from. The statistic is just the basics. Now actually KonText is not the only tool with which we can query the corpora. The second tool is PeerMultiQ. So it is not, you just not need to read this. It is just an illustration how you can query the corpora, the syntactically annotated corpora. You can either get what you get in the KonText. It is the list of sentences, or if you query with the PeerMultiQ, you can get a list of trees. And what we want to do in the Lindat KonText is kind of combine these two things and include the syntactic information into the KonText too. So here is the hybrid system, what you get if you merge those two. So actually the base is that in Lindat KonText you get what you have in KonText. It is the list of the concordance, the list of sentences. But you can click on the icon that will show you the trees as they are displayed in the PeerMultiQ. So you will not be able to browse those trees, but at least you will just see them and see the attributes of them. And so on. So just briefly about the Corpus Query Language. it is CQL, and it has, just to remind you, the structure attribute. Attribute equals some value, and traditionally in the Czech National Corpus, you could put the query you could query for the form, for the lemma, and for the tag, plus some other attributes derived from the three, like for example pos, part of speech, that is derived from the tag, or lowercase form, and some others. Here is some artificial example. And in Lindat context, when we tried to include the syntactic information, we introduced some more attributes, which I will explain you on the next slide. For example, here is this attribute, parent afun. So we introduced some more attributes from the analytical layer, from the syntactic layer. And sure, KonText has many more functionalities, like we can filter out the document IDs and so on, but I will not tell, probably it goes out of scope of this lecture, and I will concentrate on the syntactic attributes in the context. So these are the attributes that we introduced. Some 1.5 years ago, when we first tried to introduce the syntax, so we added only one attribute, which was analytical function, or afun. I have the deprel in the brackets because in the international community, the term deprel is used more than afun. So, for example, for the universal dependencies, we use the term deprel. And for the Prague Dependency Treebank, we'll use the term afun to be consistent with the Czech National Corpus. But maybe we will also, it is disputable, so maybe we can unify all our terms to the deprel or either to afun. So as you can see that here how we decided to capture the syntactic structure of a tree. We can query for the information of a parent, for the parent form, parent lemma, parent tag, and the analytical function of a parent, and the same for the effective parent. And we also introduced some other attributes, which was first called immediate or distant. It was supposed, it's not here in the slides because it is not, we cannot search for these attributes anymore. So it was the query like if the parent stands on the right or on the left from the node, or if a parent is immediate or distant. But there, in order to be consistent with the Czech National Corpus, we decided to change to these attributes, to another attribute which is called parent and parent. It also illustrates the distance from the node. So the parent plus 3 will means that the parent stays 3 nodes to the right, and the parent minus 3, it will mean that the parent is 3 nodes to the left. So now I will go and try some queries in the universal dependencies. But before this, I will just show you what the universal dependencies treebanks are. So as I mentioned, they are treebanks of 38 languages. And as for the morphological information, we included the attributes called POS, part of speech, that was suggested by the Google, so a set of universal part of speech. As for the tags, the universal dependencies use the intern set that was suggested by Dan Zeman. So it is can be transformed into a positional tag, and on the contrary. So if in positional tag you have some dots in the position that are not relevant to this word form, so here you don't have these dots, but you have instead the attribute and the value. So it is actually when you can imagine that before it in the query to context when you put tag equals and then some regular expression, verb dot star something. So here to query this corpus, actually the regular expression will be much more difficult. So you will have to enter like dot star and then case nominative, then dot star and so on. But we will think over how to make it more simpler. As for the syntactic information, the scheme used for the universal dependencies is Stanford dependencies. So all of this information better refer to the web if you will need some to learn the values of the attributes. So here is the statistics of the views of universal dependencies in Lindat corpus. And it is just for information, I will not go into the detail, the set of universal part of speech. So you can put the query to the corpus, boss is adjective, and this is an attribute called ufit, a tag from the interset. So tense is past, for example, the verb called. Here you can see the number of the attributes, and they have different values, which you can see in the corpus. So here is a list, here is a list of syntactic of dependency relations, names, and there are many more of them. They did not go into one slide. Next I will demonstrate some examples, but just some disclaimer that they are just illustrations of queries and they are not some meaningful linguistic research. So just to illustrate how to query those tree banks. So first let's start. Let's go to the Lindat context. Here is the main page of Lindat KonText, and you can see that there are parallel corpora, monolingual corpora, and speech corpora. You can find the universal dependencies in the monolingual corpora, so they are not parallel, those treebanks. And here you can see the list of treebanks. So it is Arabic, Basque, Bulgarian, Ancient Greek, and so on and so forth. Here is a download link, so when you click download, you will not download it, but it will go to the repository. And here is a link to PeerMultiQ tree query, so if you will not be satisfied with this linear search in context, you can go and browse this tree bank in the PeerMultiQ. What's this? It went to PeerMultiQ. So first you have to log in. I will now show you the procedure because it is rather intuitive. It uses such called shibboleth. So I will just log out, and then when I click log in, you can enter the username from the that you probably have from the SIS, and you are logged in. I strongly recommend you to log in before using the system because so you don't have to register to send some request or anything. You just use your university ID to log in, and because it will open you much more functions. So now let's try the first query. as I told you, I will have some artificial examples and some very simple examples. As you know, in Romance languages, like in French, I will give an example from a French language. The adjective generally goes after the noun. But now this query will filter those cases where this is not so. So it will find the adjectives whose parent is noun and whose parent stands on the right. So it is the adjective noun, just like in, for example, in Czech or in some other languages. So here it is. And here is the concordance. So you can see those adjectives, and if we then click on the frequency and the note forms, then it will show you the adjectives like autre, première, même, and so on. Pardon my French. They come before the noun. And the same, we can execute the same query over, for example, Polish treebank. So let's do this. Just let's copy the query. The query. So the same can be done for any of these languages, the treebanks. But now I will not do it for Polish because the result will be more or less the same as for French. I want also to introduce one more thing, which I compiled. I made an artificial compilation of all of these treebanks. It is just a support treebank. I took 5,000 sentences from each of the treebank, put them into one, and you will ask, what is it for? What is it good for? But I just did it in order to see which attributes are relevant for each of the treebank. For example, you can see this list of treebanks, but as they come from different institutions, in some of the institutions they have the annotation of the multi-word expressions. In some treebanks they do not have. So if you query this unified, you can see in which treebanks you have this or that type of annotation. So it is kind of support. But you can also think probably that you can make some other things with this. So let us choose it and put this query, and maybe let us do it the opposite way. So let us filter those cases where the noun, where the adjectives goes after the noun. So what you have. It is just the mix. It doesn't make sense, this concordance. But again, if you click on the frequency and the document IDs, so these are generally the names of the corpora. I put only one name. It is the file that is included in the Universal Dependencies. So you can see that on the top there are the languages for which this order of noun and adjective, like noun adjective is typical. This is Spanish, French, Portuguese, Italian. So these are the Romance languages that are on the top of it. And on the bottom, there are some Slavic languages. So somewhat, not Slavic. Okay, so for example, in Tamil, there is no such construction at all. Okay, so let's come back, and our second query will also demonstrate the word order issues. But here we will try to see the statistics of using the SVO order, or better I eliminated the object from this query, because it will be much more difficult to query it. And I will just search for a predicate that goes before the subject in English language, which is, in English it is the opposite, so we will search for the cases where the predicate goes before it. So I just, here it is just a small note, because when you query just for morphological information, you will say like the part of speech is noun, or the tag is noun dot star, and then the verb, and so on. This will be much more complicated query than just saying querying for using the dependency relation. So this will demonstrate the dependency relation, which is for subject, and the parent of it is a verb, and the dependency relation of a parent is root, so it is a verb, and we'll eliminate all the forms of the word to be, because it is like there were many students in the room, so it is not the case. And the parent stands on the left, so the verb stands on the left. Let's execute the query. And you can see that it is generally in the sentences like says someone, said, read, and so on. And then you can, again, sort it according to the, or maybe better according to lemma, according to parent lemma. Make frequency list, and it returns all the words where you have this situation. So it is typical for the words say, have, ask, write, take, suppose, and so on and so forth. And let us try to execute the same query, to put the same query to this united joint treebanks. And see which languages demonstrate this behavior. So for, yeah. So again, you can see some kind of a meaningless concordance, but when you sort it according to the frequency of the documents, you can see that this order is typical for the German. So, komm, ich, I don't know, you give an example of those who, for those who know. The Dutch, Danish, zu, it is Old Church Slavonic, and then Czech, and so on. And in the bottom, one of the languages is English, Hindi, and some Romance languages in between. So that is how you can search in the universal dependencies. Let me show you one more feature. It is better to show it probably on the English. So as I demonstrated you in the very beginning, we have a functionality which is called tree view. So you can see the concordance, but you can also see the tree. So you go to the end and you can see the symbol, browse the tree, and you can click on the tree, and here is the tree itself. Then you can click on some attribute, click on some word, and here on the left you will see the attributes and values. But actually you cannot query all of this, but I did all my best to include the most. So you can query, for example, for feet, features, universal features. And so I think that this will be good to see those attributes of trees. Just for example, you have this universal dependency treebanks, but you don't know what is inside. And here you can just put some query and open the tree and see which attributes are included and so on. Or you can use that join treebank so to filter out which of the treebank use which annotations, attributes, and so on. So that was all for the universal dependencies. Now I will demonstrate you some search in the Prague Dependency Treebank. Prague Dependency Treebank, in the Prague Dependency Treebank, the sentences are annotated on several layers, but in KonText we will use 3 of them: morphological, analytical, and tectogrammatical. Actually, the morphological and analytical layers are processed quite nicely in KonText, but as for the tectogrammatical layer, it becomes more difficult, and I will show you why. So here are the attributes that we decided to add to the Prague Dependency Treebank. So the attributes of the nodes are word lemma tag. And here we will use, so as we switched to the Czech soil, we will use the afun, not the prel, but it is kind of the same. So on the analytical layer, we decided to include the ord, which illustrates the order of a node in a sentence. Close number is member illustrates if it is a member of coordination or not. So this analytical function, and the type, which can be either lexical or lex or aux. And on the T layer, actually the attributes from the T layer are in the beta version. So it is. I have to develop some strategy towards handling those attributes in tectogrammatical layer because it is quite difficult to illustrate, for example, such things as discourse or coreference, because they go because coreference and discourse, they go generally beyond the sentence or beyond the clause, and it is quite difficult to capture this in KonText. And again, the attributes of the parent that I already demonstrated: parent form, parent lemma, parent tag, parent analytical function, and parent, which illustrates the distance. The same for the effective parent. And I will not explain you all of these attributes on the tectogrammatical layer. Please refer to the PDT manual. Okay, so let's try some queries. Again, remember the disclaimer that this is not a meaningful linguistic research. So it is just an illustration of what you can do with it. So our first query will be the query that you already saw. Let us just have a look in how many cases the order of a subject and a predicate in the Prague Dependency Treebank. So you can search and find that there are more than 15,000 of such cases. And again, let us try, for example, when the predicate stands on the left from the subject, and you will see that there are less of them. So that is the kind of research that you can do in the Prague Dependency Treebank. Sure, you can do it in PeerMultiQ, but here you can use all the functionalities of KonText. So you can create the subcorpus and so those syntactic function, the dependency relation and the distance from the node can really make a difference. And it is some enhancement in comparison with only morphological search. So let us have a look at the second example. Okay, the second example, I just told you it was the verb and subject order. So the third example illustrates the position of the reflexive particle se, and I will filter those sentences where the reflexive se stands 10 positions distant from the verb. So here is the lemma is se, the afun of the effective parent is predicate, and the parent is this is the plus. It should be escaped according to the regular expressions, and so this number is 1, 2, and some other. So it is 10 or more. Where is this query? And we search for it, and here you can see those sentences. Okay, so here is the sentence where the reflexive particle stands far away from the verb. And let us change a bit this query. Let us query for the sentence where this se is really far away from the verb. If we find such, and yes, there are 4 of them. So, to se mu mimochodem díky pochopení generála and blah, blah, blah. So, the verb is really far away from the particle. Okay. And actually, I tried somehow to write some regular, the query which will calculate the SVO order, which will filter out the sentences with SVO, then with SOV, and so on. But it was quite difficult to do this because the KonText is kind of a linear search engine, so you can search in the clauses. So the problem is when, for example, there is some clause, there are 2 clauses, and the KonText will find the subject from the one clause and say the object from the other clause. So, well, sure, you can put many of those positions, but it will be really a long query. But I think that it is doable, but better to use PeerMultiQ where you can query the tree. So you will see that. Just find the left brother, right brother, or find this. So, okay, and finally, there is a query for an auxiliary word, a member of coordination. So just some of the examples. Okay, now let's go to the examples from the tectogrammatical layer. So now what we have stable is the syntactic annotation, and it is also used in the Czech National Corpus, so the people do really know how to use, I think that they will in a short time use those attributes like parent depra, or like the dependency, the afun of a parent, tag of a parent, and so on. But actually, as for the tectogrammatical layer, it is quite doubtful if we should use it or not. So I included the attribute, which is called functor, or the deep function. For example, here is the example of functor. It is means, and in means, this functor generally expressed by the noun in the instrumental case, and here with this query, we will try to see in which cases the means there is some other case. So here is the query, and let us search. So here are some. Here is the concordance, and again we can sort according to the tag. See, yes, make frequency list. So you can see that as for the functor means, the first one is certainly the instrumental case, but then goes genitive, accusative, and some others. So here is another example. This is DPHR. It illustrates the idiomatic expressions. So with this query, we will find the idiomatic expression of length 3. Let us try this. So you can see the examples of the idiomatic expressions. Jako po masle, na stejné lodi, na lehkou váhu, mraz po zádech. So I think that it is a good thing to have this functor in the Prague in KonText. So, for example, you should not go to the PeerMultiQ and to query for all these things. It is much more easier to do it in KonText. Okay, so also you can try this, the two, and you will see many more idiomatic expressions like dispozici za důsledek, z kopce na svět za důsledek, and so on. So the next query will concern topic focus articulation. It is just again some artificial query. Probably you will come up with a more meaningful one. So here is where the predicate stands before the predicate goes before the subject, and the TFA attribute is focus F. Let's search. And here are those cases. So again, you can see that this attribute can be also very useful, and you can query the corpus with this attribute. So the next query. Yeah, and now there are two quite disputable cases, reference and discourse. As I told you, it is not very intuitive and probably not a good idea to include this into KonText, because these are the coreference. The coreference chains cannot be expressed in KonText because it will not go through the borders of a sentence. But at least what you can do is to query for some attributes of the coreference. Say there is an attribute which is called coref special, and when it is not identified on many words, but on the words that it is identified, we will just see it. But when it is not identified, there is the symbol. Okay, so let's search. And you can see all those cases where there's a graph special is identified, and probably we should put the view options and have a look at attributes and structures. So where is this graph special? Yes. Okay, so you can see that that those attributes are actually segm or exof. Exof means that the reference type that this reference is, it refers to something which is not in the text, and the segment, it means that it is inside it. But actually, I wanted to include more information from the reference. But for example, you can query for the, as in the case with parent, you can query for the parent, for the tag lemma of a node in this chain, but it is just in the phase of development. So we have not decided if to include this reference into the tree, into this tool or not. The same is with discourse. So you can, for example, query for the sentences where the discourse type is opposition. So here are those sentences. Stal se však zázrak, or you can see that the word of však, but is used many times in it. So and again, my initial plan was to add, for example, connectors. So you can query, you will say that finds the sentences where where the discourse type is opposition and the connector lemma is this or that. But again, there were some difficulties in the treebank schema because just the context query system does not support those relations between the words. Does not support this referencing, unfortunately. Okay, so that was probably the last query from the Prague Dependency Treebank, and that is what my message is. So searching in the trees with the CQL resembles this creature. At least this is my opinion, because the trees, because PeerMultiQ is a language that is suitable for querying them. And here we added some functionality, added some syntax. Okay, we can add some attributes from tectogrammatical layer like topic focus or functors or some T-lemma or something, and it can really bring us some instruments, but they are not natural to this system. So that is what I think about searching in trees, but still it may bring some results. So now I will demonstrate the last thing I will demonstrate the queries from other corpora, from other Lindat corpora. Here is the Czech legal text treebank. Oh. Yes, here it is. So I executed the query. Where is query overview? So you can see that I will search for the lemma, and effective parent of a lemma is a verb. Just a simple query. And here you can see, also you can see the trees, and you can see the trees can be really, really big and large, very large. And you can also click on the nodes and see the respective attributes and so on. Okay, so that was another tree bank. And now let's go to some to other corpora. So let us have a look at speech corpora, namely on vestidial. So we put some, I don't know, ale. Oh, what? Okay, basic. It should be basic. Basic query, and here you can see the sentences in which it occurs, and you can click on plus. Oh, my laptop. Okay, so you can find this type of corpora here. And also, if you want to learn, for example, the Serbian accent in English, let us listen to it.
Lalish 2 decimal arrival Cubana 472 Echo.
Yes.
The Riberia 1 decimal Sierra and what about 340?
Okay, this is the Serbian accent. And the next corpus of another type. So as I told you, there are many corpora in Lindat, and they have many various kinds of information. There is one corpus with sentiment analysis, with the annotation of sentiment. Here it is. It is called the Facebook data for sentiment analysis, and in this corpus, each sentence is annotated with some polarity. So the polarity of a sentence can be either negative, positive, or 0, which is like neutral. Here in this query, I searched for the sentences with a negative polarity, but with the sentences that contains this sign. So this will kind of illustrate all the sentences with some ironical smile, which is actually a negative. So again, let's click on it, and yes, we'll have this. So this sentence, for example, byla to hruza with a smile, it is kind of ironical. So it was horrible, and the smile. So as you can see that actually you can include very different kinds of annotation into this tool. So our plan is to make available each corpus from Lindat via KonText, and to put all the possible information as possible to the system. So that is the end and the conclusion. So I demonstrated you how the KonText tool was adjusted for a search for browsing Lindat corpora. And I also showed you the functionality that we added. It is a tree view, and here are the plans for the nearest future. So as I told you, our main goal is to make all the Lindat corpora available via KonText, except for the corpora from the Czech National Corpus, because they are already available. Then we are going to parse the corpora without annotation. For example, that corpora that I show you, the speech corpora or the sentiment corpora or some other are not annotated. Does not have any special annotation. So I will probably parse them so that all the attributes like parent, afun, and so on can be available. And also, I should work more on the PDT attributes from the tectogrammatical layer. And if you if some of you have the ideas about which attributes to leave and which attributes rather to eliminate, I will very much welcome if you will give me some advice on this. And I also want to write a short manual for each corpus because now the people who, for example, come to the page of the Universal Dependencies, they see this context, they open it, and it is totally an unknown tool for them. So we should make something more, some visualization example of the queries like I just demonstrated you, so that people can browse this tree banks. And the long-term goals may be to introduce some kind of word sketchers, the statistics of the words, and to make the connection to the dictionary. So for example, if you have this concordance, you can click on the word and not click, just point to the word and have the translation of the word, and maybe the connection to the valency lexicon, and maybe it is also a long-term goal, some word alignments for parallel corpora. So thank you for your attention, and I'm looking for the discussion.
So thank you very much for your presentation. Now we have some half an hour for discussions. Please, your questions or remarks or suggestions as for us.
Did you consider including parallel corpora like Cheng in the same way as you included trees? I mean, could you, like now you have had duplicates of the parent attributes like parent tag, parent something, so aligned node something. Could it be the case? Could it be done?
Yeah, sure, it can be done. Actually, because we just started with this annotation, so we started with the monolingual with the monolingual corpora. But it was my plan also to. So you can see that actually Cheng is included into it, but so far, Czech English parallel corpus, yes. It is Cheng, but it is the older version. So when there will be the Cheng 2.0, and well, when it will be parsed up maybe to tectogrammatical layer or to whatever, or to even on the level of syntax. So far we have these old annotations, so you can only query for the analytical function. But I plan also to introduce it like this too, so you can query for the parent lemma, parent tag, parent affun in both languages.
Okay, but can you connect them? I mean, can you ask that word, whatever, dog is aligned to this English word to that Czech
What?
word?
Not yet, no.
No, it isn't there.
What?
I mean, it is there.
It's there.
I just tried.
Okay, thank you.
What? The dog.
The parallel corpus in
Switching. Oh, okay. Yes. Switching is there. Yeah, sure. I thought that you were asking about searching. Yes. Yeah, sure.
If you can search for a certain alignment of words. So can I search for house being aligned to blue?
No.
But that's what you have in your nearest.
Yes. Right.
So it will be there.
Well, nearest it is a long-term goal. It's.
I'm sorry, the parallel search is not possible. You can search for house and you can search.
Yes.
You can get the search for word to word alignment.
But there is no word alignment in it, so maybe that would be a nice feature. Of course. So we should work on it. No.
So, some other questions or remarks?
Just about what you spoke about, you can search in parallel corpora, you can search for house and something like house in the same sentence. It helps. I have spent some hours with parallel searching, kind of word alignment, but manual hand alignment, and it worked somehow. But just I wanted to say something else. When you About PDT search, can you see both trees, analytical and tectogrammatical?
Yeah, that is a good question because actually, as we just started with this tree view, it is not yet included into it. But we will have to think about which features to include. So I can generate both analytical and tectogrammatical trees. So if you search in PDT for some lemma set, then you can click on the tree, and then yes, it is the plan for, it is the nearest future. It will appear in 2 weeks, I say, or something. So you can really search, and you can click on it, and you'll get both analytical and tectogrammatical tree, like here now, like here. Yes, you can. So far you can't, but I'm working on it. So, so far you can see only the analytical tree.
And one more little thing about coreferential features and tectogrammatical on tectogrammatical attributes. Possibly, if you already have this segment and exophora coreference without antecedent, it could have sense to have also nodes which have some coreferential link. So possible, even if you can't connect them to other sentences, it could help just to be able to find nodes which have some coreferential relations to some preceding context. Because somebody in linguistic society, Czech linguistic society, could search for such nodes in connections with lemma attributes or TFAs or informational structures, something like that.
Maybe because I included one thing that I was not sure about what it is, but I just included it. Say antes is not this thing, so it is not empty, and I don't know if it will give me this. I'm not sure what it is because I'm not a specialist in coreference. So let's see the antes. Apply view options. I'm not sure is it this relevant or not. So this word hrači was in the PDT. It is tagged with. So it is in the antes. You can see the lemma. Well, I'm not sure. We should discuss it. So there's something included, but I don't know yet how to use it, and I should work more on this. So the discourse and coreference are just in a very preliminary version. It's not even a better version. It's some very beginning.
Yeah, I have more queries, so maybe I just pick some and ask later. What about graphical queries? If did you think about any way how to once you have the graphical output, the tree? So maybe at some stage you'd like to consider asking queries about syntactic structure in some better way than fiddling with those attributes in
but PeerMultiQ is for this.
Okay, so you would say I should use PeerMultiQ.
Yes.
Okay.
If I may, it's not a goal of this small integration to substitute PeerMultiQ completely.
Okay.
So it is just introduces some more nice attributes like functor, like TFA.
Okay. Am I right that in this PDT there is not this tree output yet?
Not yet, because I'm working on including also the tectogrammatical trees. So far I can generate only analytical one, but they can be analytical and tectogrammatical tree. So you open and see them both in the nearest future.
Okay, you showed a nice example how to search for multi-word expressions in in PDT,
Yes,
right?
yes.
And I wonder how to phrase such a query so that you would actually get all the components of the multi-word expression.
All the components.
So if I ask just for this DPHR,
Yes.
and then
I can't remember where it was.
then 2 and more tokens.
2 and more,
So-
yes.
So I do not necessarily get all those tokens in the
Maybe you should try.
yeah.
These are just
So-
the examples to play around, you know. So
Yeah,
you can think about.
I don't actually know how to ask for multiple tokens all having the same factor.
All having the same.
In a sequence.
In a
without-
sequence. So it is function. Yeah.
I think you can ask that there are one or more NBE, and then another factor afterwards, and another before.
You can try the query here.
Oh, so multiple queries, right? Or,
Just
no?
one query there.
Like say, there is some factor other than DPHR, then as many DPHRs as you like 2 or more, and then something else. So the query will match the 2 words that are not part of the
Okay.
words.
So just
But you also
putting
have this-
kind of bracket around.
Yeah.
Yeah. Okay. Yeah. You said you'd like to include some help or
Yeah, someone
introduction
help.
for maybe the queries that you
Yeah.
you showed, they would be a nice part of that help.
Yeah, that is what I actually plan. So somewhere here or here will be a link. Like click on it and you will get the examples. Or maybe I just want to consult with you. Is it okay? So there will be some on this they will be right on this page, so that people when they get to this page, especially people coming from for the universal dependencies who are not familiar with this. So maybe as they see this query, like attribute, like lemma is something, they will just put it and start with it. But
Okay, and if I may, I'm trying to to understand my notes. I wonder if you have any ideas how to actually search for individual positions in the positional text set, or in the or in universal dependencies for these attribute values. Is it in the direction of having a menu, a clickable menu, or would you think about something?
well, we were discussing, we
basic?
were having these discussions with Pavel, so maybe you can pass him microphone. But
Okay.
now you can just query only with the regular expression, with this terrible regular expression, like because there are a lot of attributes and a lot of values to the attributes. It will be quite difficult, I think, to do this.
Yeah, we realize that the current system, especially with universal dependencies, is very hard to pose some queries with the flexibility in them. It's very inconvenient it's almost impossible to do it with regular expressions, right? But on the other hand, the current system that people are used to, using regular expressions over Prague dependency, over the so-called HH tags, is it's convenient if you know them, but it's completely confusing for people who don't know them. So the broad plan is to definitely go for something more graphical in terms of composing this SQL query. I think a good example that we like is something that they have if you've seen a system called Corp that is being developed at the Språkbanken in Sweden, and the Finnish National Corpus is using it, and several other sites. It's very simple abstraction of basically a big box representing a word or a token, and you just line those boxes, and each box can be filled with menus. You just put more and more attributes into the box and fill them with menus, and then you can, if you decide that you want to change the order of words, you just swap the boxes. And it's still linked to the CQL expression, so you can switch between the CQL and the graphical abstraction. So something along those lines, but we are not there yet. If somebody wants to give us a hand in development, that would be wonderful. Excellent question, yes. I think it's one of the major problems of new people actually coming to KonText and being able to efficiently query the way how to represent the expressions, especially if I want some flexibility in them. Yeah.
I have few comments mixed with questions. So first, I like this tool. I think it will be useful for some users. I'm comparing with the PeerMultiQ, so even I know the syntax of PeerMultiQ, I always forget it, and this is, I think, more difficult to forget, the CQL. And also, I think one advantage, and that's the question, I think you can index much bigger data. So like even automatically parsed corpora with gigawords. Is it true that the KonText can index it also including the parent attributes?
Yes, we have an attempt, but I have not shown you because it is in the older version.
Which would not be possible in PeerMultiQ.
Yeah, okay, so it is called syntactically annotated corpus.
Yes.
So we see by Hanka Skumalova automatically parsed it, and you can query for the parent, e-parent, and so on.
Yes, you said that you don't want to substitute PeerMultiQ, I understand it, yes. And you showed a picture of the creator, but I think there are several use cases for this, and I think the big data, big corpora are one of those use cases. And also, do you have in Lindat logs of the PeerMultiQ queries? Probably yes. And the question is, can you estimate what portion of those PeerMultiQ queries could be expressed here in KonText? My guess is over 90%. But well,
really?
You can.
You think so?
I think so. I think mostly users, even when asking about trees, ask for parent and not
left
grandparent.
Brothers and right brothers, or.
Well, this is just a wild guess. You need to check it, but I think that most of course, then you have one use case which is crucial for your thesis or whatever, and you need to switch to PeerMultiQ anyway. But
oh, it is quite optimistic, 90%.
I don't know.
Estimation.
You need to say.
But.
And one last comment is, you said that CQL is not designed for tree queries. That's true, but I think the main problem is not that it's linear, but that is the absence of co-indexing.
Yes,
for example, there the question about SVO order or whatever was, are those, I want those two words to have the same parent. And this would be easily possible in the language with some variables or whatever, but I'm not sure if it's not there or if it's only in the internal version used by the server, but definitely it's not available for the users. So that's maybe for the KonText developers a question.
I think it actually is there. I'm not quite sure. I just remember it a little bit from the thesis of polarity, but then it runs into the same problem as PeerMultiQ over big data. It gets slow. So I think it is there. I think it is used in some computation of sketches. So something like that is in sketch grammars, but it's definitely not.
Maybe are you speaking about this
yeah.
referencing or not?
So I think you can have references.
So you can ask for a subject and object
come here and help me what you mean.
I haven't seen this syntax before.
Yeah, actually, I also haven't seen, but the syntax, because it is not generally used. But if you can, some of you is more experienced in query and the corpora, can you help me?
Yeah,
Someone?
Yeah, well, we can
So-
refer to the value of two attributes of two tokens.
So-
you can say that the value should be the same. It's written down.
And so how, Sasha, can you please try and rate it?
So this could be our attribute, which needs to be the same.
So let us try it.
I think Pavel wants to speak. No, sorry.
I said that I don't know much about this, and I don't want to solve it now.
No, that's,
So, anybody,
I don't know.
anybody to ask a question or maybe comment?
Perhaps just a short suggestion. Do you have, well, in the context used in the Czech National Corpus, there are some so-called dynamic attributes which are computed out of.
Yes.
Yes, it would be. I don't know if whether it is used here as well.
Here not,
like
but we can
case,
use them.
Case, part of speech. For well, in the case where you.
Even this.
Yes, precisely that. Because for
It
Czech,
helps.
for example, it's very useful. For example, when you were querying for the means, and you had that list of starting with feminine singular genitive and so on. If you just made the frequencies not of all tags but just case, then it would have been much.
Yeah, you're
much
right.
More, but
You're right.
I don't know whether it is used. So you do have it.
We can
Or
do this.
This little C down there, under the post, is
Yes.
it case?
Yes, maybe, I don't know. It is the older. It is the older version that I came to because I started to work right away on this parent F1s, and so on. And this was I taken it for granted. So this
Yes,
is
because this is quite useful in when you use it while querying syntactic attributes. It helps very much. Just to have the case of your the parent or the not.
But that is also how we can handle the universal dependencies. We can actually have different position or derived attributes. Like for example, we can enter gender is something and just have the attributes for them, but it will. But this file, this vertical file from it generated, it will be very, very light. It will have very many attributes, but we can test it.
Yes, the advantage of the dynamic attribute is it is computed by the engine itself, so it does not have to appear as a.
So I should think about
in the data.
Yes, I should think about it.
We have spent our time for discussion in a very constructive way for both sides
thank you for help.
of the discussion. Thank you very much for presenting your proposals. Thank you very much for being here and taking part in the discussion. And we will meet next Monday, and Tomáš will be the speaker if I know that. Okay, so see you next week. Thank you.